Okay, hey everyone, looks like we're on. So as usual, if you have not yet, please enter your SUID so that we know you're here in this room. So actually, can you hear me okay at the back? Is this okay? Oh, yes, is the volume okay at the back? All right, no one's responding. Yes, okay, all right, thank you. Okay, so what I want to do today is share with you two things. You know, we're approaching the end of the quarter. Hope you guys are looking forward to the Thanksgiving break next week. Actually, and I guess we have a lot of home viewers, but those of you that are viewing this from outside California know that we're all breathing really bad air here in California. So I hope if some of you are watching this at home, you have better air wherever you are. What I hope to do today is give you some advice that will set you up for the future, so even beyond the conclusion of CS230. And in particular, what I want to do today is share with you some advice on how to read research papers, because deep learning is evolving fast enough that even though you've learned a lot of the foundations of deep learning and learned a lot of the tips and tricks, and you probably know better than many practitioners how to actually get deep learning algorithms to work already, when you're working on specific applications, whether in computer vision or natural language processing or speech recognition or something else, for you to be able to efficiently figure out the academic literature on key parts of the deep learning world will help you keep on developing and staying on top of ideas even as they evolve for the next several years or maybe decades. So first thing I want to do is give you advice on how when I'm trying to master a new body of literature, how I go about that, and hope that those techniques will be useful to help you be more efficient in how you read research papers. And then the second thing is, in previous offerings of this class, one request from a lot of students was just advice for navigating a career in machine learning. And so in the second half of today, I want to share some thoughts with you on that. Okay. So it turns out that, I guess two topics: reading research papers, right, and then second, career advice in machine learning. So it turns out that reading research papers is one of those things that a lot of PhD students learn via osmosis, right? Meaning that if you're a PhD student and you see, a few professors or see other PhD students do certain things, then you might try to pick it up by osmosis. But I hope today to accelerate your efficiency in how you acquire knowledge yourself from the academic literature. Right? And so let's say that there's an area you want to become good at. Let's say you want to build that speech recognition. All right, let's turn this off for now. Let's say you want to build that speech recognition system that we talked about with the Robert Turn-on and the DESLAM. Right? This is what this is a sequence of steps I recommend you take, which is first, compile a list of papers, and by papers, I mean both research papers, often posted on arXiv or on the internet, but also plus Medium posts, or maybe some occasional GitHub posts, although those are rarer, but whatever text or learning resources you have. And then what I usually do is end up skipping around the list. Right? So if I'm trying to master a new body of knowledge, say you want to learn about speech recognition systems, this is what it feels like to read a set of papers, which is maybe you initially start off with 5 papers, and if on the horizontal axis, I plot, 0% to 100% read / understood, right? The way it feels like reading these papers is often read, 10% of each paper, or try to quickly skim and understand each of these papers. And if, based on that, you decide that paper number 2 is a dud, right? Other authors even cite it and say, boy, they sure got it wrong. Or you read it and it just doesn't make sense. Then go ahead and forget it. And as you skip around the different papers, you might decide that paper 3 is a really seminal one, and then spend a lot of time to go ahead and read and understand the whole thing. And based on that, you might then find the 6th paper from the citations and read that. and go back and flesh out your understanding of paper 4, and then find a paper 7 and go and read that all the way to the conclusion. But this is what it feels like as you assemble a list of papers and skip around and try to master a body of literature, right, around some topic that you want to learn. And I think some rough guidelines, if you read 50 to 20 papers, I think you have a basic understanding of an area, right? Like maybe good enough to do some work, apply some algorithms. If you read 50 to 100 papers in an area, like speech recognition, and kind of understand a lot of it, then that's probably enough to give you a very good understanding of an area, right? You might, I don't know, I'm always careful about when I say that you're mastering a subject, but you read 50 to 100 papers on speech recognition, you have a very good understanding of speech recognition. Or if you're interested in, say, domain adaptation, right? By the time you've read 50 or 100 papers, you have a very good understanding of a subject like that. But if you read 5 to 20 papers, it's probably enough for you to implement it, but maybe not sure if it's enough for you to do research or be really at the cutting edge. But these are maybe some guidelines for the volume of reading you should aspire to if you want to pick up a new area. Right? Or take one of the subjects in CS230 and go more deeply into it, right? Now, how do you read one paper? And I hope most of you brought your laptop. So what I'm going to do is describe to you how I read one paper. And then after that, I'm actually going to ask all of you to download the paper online and just take take a few minutes to read a paper right here in class and see how far you can get understanding a research paper in just minutes, right here in class. Okay. So when reading one paper, so the bad way to read a paper is to go from the first word until the last word, right? It's just a bad way to when you have a paper like this. Oh, and by the way, actually here, I'll tell you what my real life is like. So I actually, pretty much everywhere I go, when I have my backpack, this is my actual folder. I don't want to show. This is my actual folder of unread papers. So pretty much everywhere I go, I actually have a paper, a stack of papers is on my personal reading list. This is actually my real life. I didn't bring this to show you. This is in my backpack all the time. And I think that, I don't know, these days on my team at Landing AI and DeepLearning.ai, I personally lead a reading group where I lead a discussion about 2 papers a week. But to select 2 papers, it means I need to read like 5 or 6 papers a week to select 2, to present or discuss at the Landing AI and DeepLearning.ai reading group. So this is my real life, right? And how I try to stay on top of the literature. And I'm doing a lot. If I can find the time to read, a couple papers a week, hopefully all of you can too. But when I'm reading a paper, this is how I would recommend you go about it, which is don't go from the first word and read until the last word. Instead, take multiple passes through the paper. Right? And so, step 1 is read the title, the abstract, and also the figures. Especially in deep learning, there are a lot of research papers where sort of the entire paper is summarized in 1 or 2 figures in the figure captions. So sometimes just by reading the title, abstract, and the key neural network architecture figure that just describes what the whole paper is about, and maybe 1 or 2 of the experiment section, you can sometimes get a very good sense of what the whole paper is about without hardly reading any of the text in the paper itself. Right? That's the first pass. Second pass, I would tend to read more carefully the intro, the conclusions. Look carefully at all the figures again, and then skim the rest. And I don't know how many of you have published academic papers, but when people publish academic papers, part of the publication process is convincing the reviewers that your paper is worthy for acceptance. And so what you find is that the abstract, intro, and conclusion is often when the authors try to summarize their work really, really carefully to make a really clear case to the reviewers for why they think their paper should be accepted for publication. And so because of that maybe slightly unusual incentive, the intro and conclusion and abstract often give a very clear summary of what's the paper actually about. And depending on again, just be bluntly honest with you guys. The related work section is useful if you want. It's sometimes useful if you want to understand related work and figure out what are the most important works in the papers. But the first time you read this, you might skim or even skim the related work section. It turns out, unless you're already familiar with literature, if this is a body of work that you're not that familiar with, the related work section is sometimes almost impossible to understand. And again, since I'm being very honest with you guys, sometimes the related work section is when the authors try to cite everyone that could possibly be reviewing the paper to make them feel good and then hopefully accept the paper. But so related work sections are sometimes written in funny ways, right? And then step 3, I would often read the paper, but just skip the math. Right? And 4, read the whole thing, but skip parts that don't make sense. Right. I think that one thing that's happened many times in the research is that, the papers you read tend to be cutting edge research. And so when we publish things, we sometimes don't know what's really important and what's not important, right? So there are many examples of well-known, highly cited research papers where some of it was just great stuff and some of it, turned out to be unimportant. But at the time the paper was written, the authors did not know. No one on the planet knew what was important and what was not important. And maybe one example, the LeNet 5 paper, right? Seminal paper by Yann LeCun. Part of it was phenomenal, just established a lot of the foundations of ConvNets. And so it was one of the most incredibly influential papers. But if you go back and read that paper, another sort of whole half of the paper was about other stuff, right? Transducers and so on, that is much less used. And so it's fine if you read a paper and some of it doesn't make sense because it's not that unusual. Or sometimes it just happens that great research means we're publishing things at the boundaries of our knowledge. And sometimes the stuff you see, will realize 5 years in the future that that wasn't the most important thing after all. Right? Or what was the key part of the algorithm maybe wasn't what the authors thought. And so sometimes if parts of the paper don't make sense, it's okay to skim it initially and move on, right? Unless you're trying to do unless you're trying to do deep research and you really need to master it, then go ahead and spend more time. But if you're trying to get through a lot of papers, then, then it's just prioritizing your time, okay? And so, just a few last things, and then I'll ask you to practice this yourself with a paper, right? I think that when you've read and understood the paper, these are questions to try to keep in mind. And when you read a paper in a few minutes, maybe try to answer these questions. What do the authors try to accomplish? And what I hope to do in a few minutes is ask you to download the paper off the internet, read it, and then try to answer these questions and discuss your answer to these questions with your peers, right, with others in the class. Okay. What were the key elements? What can you use yourself? And okay, so I think if you can answer these questions, hopefully that will reflect that you have a pretty good understanding of the paper, okay? And so what I would like you to do is pull up your laptop, and then, so there's actually, so I think on the ConvNet videos, right, on the DeepLearn.ai ConvNet videos on Coursera, you learned a bit about various neural network architectures up to ResNets, and it turns out that there's another follow-on piece of work that maybe builds on some of the ideas of ResNets, which is called DenseNets. So what I'd like you to do is, so what I'd like you to do is actually try this. And when I'm reading a paper, again, in the earliest stages, don't get stuck on the math. Just go ahead and skim the math and read the English text when you get through faster. And maybe one of the principles is go from the very efficient, high information content first, and then go to the harder material later, right? Which is why often I'll just skim the math, and if I don't understand the summary equation, just move on, and then only later go back and really try to figure out the math more carefully. Okay. So what I'd like you to do is take, I don't know, why don't you take wonder if let's have you take 7 minutes. Right? I'm thinking maybe one minute per page. It's quite fast, and search for this paper, densely connected convolutional neural networks by Guohang et al. Okay. Once you guys take out your laptops, search for this paper, download it. You should be able to find this on arXiv, ARXIV, right? And this is also, sometimes you also call this DenseNets, I guess. And go ahead and once you take like 7 minutes to read this paper, and I'll let you know when the time has passed. And then after that time, I'd like you to, discuss with the others, right? What you think are the answers, especially the first two, because the other two you can leave off. But why don't you go ahead and take a few minutes to do that now, and then I'll let you know when sort of like 7 minutes have passed, and then you can discuss your answers with these with your friends, okay? All right, guys, so anyone with any thoughts or insights, surprises, or thoughts from this? So now you spent 11 minutes on this paper, right? 7 minutes reading, 4 minutes discussing, which is a really, really short period of time. But any thoughts? What do you think of the paper? Come on, you all just spend a lot of time saying a lot of stuff to each other. So, actually, what do people think of the time you spent trying to read the paper? Actually, did you feel raise your hand if you feel, you kind of understood the main concepts in the paper. Just a bit. Okay, yeah, like 2/3 of you, many of you. And actually, what did you guys think of the figures? Wow, people are really less energetic today than usual. Hope it's not the bad news making everyone not having enough to know. So I think this is one of those papers where the paper is almost entirely summarized in figures 1 and 2, right? I think I see a lot of people nodding. If you look at figure 1 and the caption there in figure 2 on page 3, and the caption there and understand those two figures, those really convey, 80% of the idea of the paper, right? And I think that a couple other tips. So it turns out that as you read these papers, with practice, you do get faster. So for example, table 1 on page 4, right? This mess of a table on top. This is a pretty common format, or a format like this is how a lot of authors use to describe their network architecture, especially in computer vision. So one of the things you find as well is that the first time you see something like table 1, it just looks really complicated, but by the time you've read a few papers in a similar format, you really look at table 1 and go, oh, yep, got it. This is the DenseNet 121 versus the DenseNet 169 architecture, and be able to more quickly pick up those things. And so another thing you find is that reading these papers actually gets better with practice, because you see different authors use different ways or similar ways of expressing themselves, and you get used to that. You actually be faster and faster at implementing these at understanding these ideas. And I think, I don't know, these days when I'm reading a paper like this, it maybe takes me about half an hour to feel like, and I know I gave you guys 7 minutes when I felt I would need maybe half an hour to figure out a paper like this. And I think for a more, and I find that it's not unusual for people relatively new to machine learning to need maybe an hour to kind of really understand a paper like this. And then, I don't know, I'm pretty experienced in machine learning, so I'm down to maybe half an hour for a paper like this, maybe even 20 minutes if it's a really easy one. But there are some outliers. So I have some colleagues, sometimes you stumble across a really difficult paper, you need to chase out a lot of references and learn a lot of other stuff. So sometimes you come across a paper that takes you 3 or 4 hours or even longer to really understand it. But I think depending on how much time you want to spend per week reading papers, you could actually learn a lot, right? Doing what you just did, but maybe spending half an hour per paper on our paper rather than 7 minutes, right? So, all right. I feel like, yeah, so I think it's great. And notice that I've actually not said anything about the content of this paper, right? So whatever you guys just learned, that was all you. I had nothing to do with it. So, like you all have the ability to go and learn this stuff by yourself. You don't need me anymore, right? So just a last few comments. Let's see. So the other few questions I get is, where do you go? The deep learning field evolves so rapidly. So where do you go so if you're trying to master a new body of knowledge, definitely do web searches, and they're often good blog posts on, here are the most important papers in speech recognition. There are lots of great resources there. And then the other thing I don't know, a lot of people want to do is try to keep up with the state of the art of deep learning, even as it's evolving rapidly. And so I'll just tell you where I go to keep up with discussions and announcements. Surprisingly, Twitter has become a surprisingly important place for researchers to find out about new things. There's an ML subreddit. It's actually pretty good. A lot of noise, but many important pieces of work do get mentioned there. Some of the top machine learning conferences are NIPS, ICML, and ICLR, right? And so whenever these conferences come around, take a look and glance through at least the title, see if there's something that interests you. And then I think I'm fortunate, I guess, to have friends, both colleagues here at Stanford as well as colleagues of several of the teams I work with that that just tell me when there's a cool paper, I guess. But I think here within Stanford or among your workplace, for those of you taking this at SCPD, you can form a community that shares interesting papers. So a lot of the groups I have are on Slack, and we regularly Slack each other or send each other text messages on the Slack messaging system when we find interesting papers, and that's been great for me, actually. Yeah. Oh, and Twitter. Let's see. Kian is here. I follow Kian. You can follow him too. This is me, Andrew Whiten, right? I probably don't Slack up papers as often as I do, but if you look at, I don't know, you can also look at who we follow, and there are a lot of good researchers that will share out these things online. Oh, and there's a bunch of people that also use a website called Archive Sanity. I don't as much sometimes, but lots of resources like that. Right. Right. Cool. So just 2 last tips for how to read papers and get good at this. So to more deeply understand the paper, some of the papers will have math in it. And actually, if you read y'all learned about Batch norm, right, in the second module's videos. If you read the Batch norm paper, it's actually one of the harder papers to read. There's a lot of math in the derivation of Batch norm, but there are papers like that. And if you want to make sure you understand the math, here's what I would recommend, which is read through it, take detailed notes, and then see if you can rederive it from scratch. So if you want to deeply understand the math of an algorithm like, Batch norm or the details of backprop or something, the good practice, and I think a lot of theoretical computer science and mathematics PhD students will use a practice like this, which is go ahead and read the paper, make sure you understand it, And then to make sure you really, really understand it, put aside the result and try to rederive the math yourself from scratch. And if you can start from a blank piece of paper and rederive one of these algorithms from scratch, then that's a good sign that you really understood it. When I was a PhD student, I did this a lot, right? That I would read a textbook or read a paper or something, and then put aside whatever I read and see if I could rederive it from scratch, starting from a blank piece of paper. And it was only if I could do that that I would feel like, yep, I think I understand this piece of math. And it turns out if you want to do this type of math yourself, is your ability to derive this type of math, rederive this type of math, that gives you the ability to generalize, to derive new novel pieces of math yourself. So I think I actually learned a lot of the math of theoretical machine learning by doing this, and it's by rederiving other people's work that allowed me to learn how to derive my own novel algorithms. And actually, sometimes you go to the art galleries, right? Like go to the Smithsonian, you see these art students, sitting on the floor, copying the great artworks, the great paintings painted by the masters centuries ago. And so I think just as today there are art students sitting in or the De Young Museum or whatever, right? Or I don't know, was it the Getty Museum in LA a few months ago. You actually see these art students, copying the work of the masters. And I think a lot of the ways if you want to become good at the math of machine learning yourself, this is a good way to do it. It's time consuming, but you can become good at that way. And same thing for code, right? I think the simple, lightweight version 1 of learning would be to download and run the open source code, if you can find it. And the deeper way to learn this material is to re-implement it from scratch. Right? It's easy to download an open source thing and run it, and then it's, ooh, it works. But if you can re-implement one of these algorithms from scratch, then that's a strong sign that you really understood this algorithm. Okay? All right. And then longer term advice. Right. For you to keep on learning and keep on getting better and better, the more important thing is for you to learn steadily, not for you to have a focused, intense activity. Like all of Thanksgiving, you read 50 papers over Thanksgiving, and then you're done for the rest of your life. It doesn't work like that, right? And I think you're actually much better off reading 2 or 3 papers a week for the next year than cramming everything, right, over one long weekend or something. Actually, in education, we actually know that spaced repetition works better than cramming. So the same thing, same body of learning, if you learn a bit every week and space it out, you actually have much better long-term retention than you try to cram everything in the short term. So this is a very solid result that we know from pedagogy and how the human brain works. So if you're able to, so again, the way my life is, my backpack, I just always have a few papers with me. And I find that I read almost everything on the tablet, I read almost everything on an iPad, but I find that research papers is one of those things where the ability to flip between pages and skim, I still find more efficient on paper. So I read almost nothing on paper these days except for research papers. But that's just me. Your mileage may vary. Maybe something else will work better for you. Okay? All right. So let's see, that's it for reading research papers. I hope that while you're in CS230, by the way, if some of you find some cool papers, or if you go further for the DensNet paper and find an interesting result there, go ahead and post on Piazza. Or if any of you want to start a reading group with other friends here at Stanford, encourage you to look around class, find a group here on campus, or among your CS230 classmates, or with your work colleagues, for those of you taking this on SCPD, so that you can all keep studying this literature and learning and helping each other along. Okay. So that's it for reading papers. The second thing I want to do today is just give some longer term advice on navigating a career in machine learning. Right? Any questions about this before I move on? Okay, cool. All right. But I hope that was useful. Some of this I wish I had known when I was a first-year PhD student, but we'll see. All right. Let's see. Can we turn on the lights, please? All right. So kind of in response to requests from students in earlier versions of the class, before we, as we approach the end of the quarter, want to give some advice for how to navigate a career in machine learning, right? So today in machine learning, there are so many opportunities to do so many exciting things. So how do you, what do you want to do? So I'm going to assume that most of you will want to do one of two things, right? At some point, you want to get a job, right? Maybe a job that does work in machine learning, including a faculty position for those of you who want to be a professor. But I guess eventually most people end up with a job, I think. Right? I guess there are other alternatives, and some of you want to go on to more advanced graduate studies. And then, although even after you get your PhD, at some point, most people do get a job after the PhD. And by job, I mean either in a big company, or a startup, right? But regardless of the details of this, I hope most of you want to do important work. Right? So what I'd like to do today is break, this into how do you find a job or join a PhD program or whatever that lets you do important work. And I want to break this discussion into two steps. One is just, how do you get a position? Right? How do you get that job offer, or how do you get that offer of admissions in the PhD program or admissions in the master's program or whatever you want to do? And then two is selecting a position. Right, but between going to this university versus that university, or between taking on the job in this company versus that company, what are the ones that will tend to set you up for success, for long-term personal success and career success? And really, I hope that, by the way, I hope that all these are just tactics to let you do important work, right? And at least I hope that's what you want to do. So, what do recruiters look for? Oh, and I think just to keep the language simpler, I'm going to pretend that I'm just going to talk about finding a job. But a lot of the very similar things apply for PhD programs. It's just instead of saying recruiters, I would say admissions committees, right? But it's actually, some of this is but let me just focus on the job scenario. So most recruiters look for technical skills. So for example, there are a lot of machine learning interviews. They'll ask you questions like, would you use gradient descent or batch gradient descent, stochastic gradient descent or batch gradient descent, or what happens if the mean batch size is too large or too small, right? So there are many companies today asking questions like that in the interview process. Or can you explain the difference between an LSTM and a GRU, and when would you use a GRU? So you really get questions like that in many job interviews today. And so recruiters looking for ML skills, as well as, and so you often be quizzed on ML skills as well as your coding ability, right? And then beyond and I think Silicon Valley has become quite good at giving people the assessments to test for real skill in machine learning engineering and in software engineering. And then the other thing that recruiters will look for, that many recruiters will look for, is meaningful work. And in particular, there are some candidates that apply for jobs that have very theoretical, that have very academic skills, meaning you can answer all the quiz questions about, what is batch norm, can you derive gradient descent for this? But unless you've actually shown that you can apply this to a meaningful setting, it's harder to convince a company or recruiter that not just the theory, but that how to actually make this stuff work. And so having done meaningful work using machine learning is a very desirable candidate, I think, to a lot of companies, kind of work experience. And I think really, whether you've done something meaningful reassures that, that you can actually do work, right? It's not just that you can answer quiz questions, but you know how to implement learning algorithms that work. And maybe, right? And then many recruiters actually look for your ability to keep on learning new skills and stay on top of machine learning even as it evolves as well, right? And so a very common pattern for the successful AI engineers, say, machine learning engineers, would be the following, where if on the horizontal axis, I plot different areas. So you might learn about machine learning, learn about deep learning, learn about probabilistic graphical models, learn about NLP, learn about computer vision, and so on, for other areas of AI or machine learning. And if the vertical axis is deaf, a lot of the strongest candidates for jobs are T-shaped individuals, meaning that you have a broad understanding of many different topics in AI and machine learning, and very deep understanding in maybe at least one area, maybe more than one area. And so I think by taking CS230 and doing the things you're doing here, hopefully you're acquiring a deeper understanding of one of these areas, of deep learning in particular. But the other thing that even deepens your knowledge in one area will be the projects you work on, the open source contributions you make, right? Whether or not you've done research, and maybe whether or not you've done an internship, right? Okay. And I think these two elements, broad area of skills, and then also going deeper to do a meaningful project in deep learning, or work with a Stanford professor, right, and do a meaningful research project, or make some contributions to open source, publish it on GitHub, and then let's use it. These are the things that let you deepen your knowledge and convince recruiters that you both have the broad technical skills, and when called on, you're able to apply these in a meaningful way to an important problem. Right. And in fact, the way we design CS230 is actually a microcosm of this, where you learned about neural nets, learned about topics like Bayes-Norm, ConvNets, sequence models, right? Let me just say RNNs. So actually, you have a breadth within the field of deep learning. And then what happens is, and the reason we want you to work on a project is so that you can pick one of these areas and maybe go deep and build a meaningful project in one of these areas, which will, and it's not just about making your resume look good, right? It's about giving you the practical experience to make sure you actually know how to make these things work, and give you the learnings to make sure that you actually know how to make a CNN work, make an RNN work. And then coincidentally, many students also list their projects on their resumes, obviously. So I think let's see, the failure modes, the things, bad ways to navigate your career. There are some students that just do this. Right? There are some Stanford students that just take class after class after class after class and go equally in depth in a huge range of areas. And this is not terrible. You can actually still get a job. You still get, sometimes you can even get into some PhD programs like this without the depth, but this is not the best way to navigate your career. Right? And so there are some Stanford students that take tons of classes, even get a good GPA doing that, but do nothing else. And this is not terrible, but this is not great, right? It's not as good as the alternative. There's one other thing I've seen Stanford students do, which is just try to do that, right? Which is just try to jump in on day one and go really, really deep in one area. And again, this has its own challenges, I guess. One failure mode, one mode that's actually not great is sometimes we actually get undergrad freshmen at Stanford that have not yet learned a lot about coding or software engineering or machine learning and try to jump into a research project right away. And this turns out not to be very efficient because it turns out Stanford classes are, online courses or Stanford classes are a very efficient way for you to learn about a broad range of areas. And after that, going deeper and getting experience in one vertical area then deepens your knowledge and makes sure you know how to actually make those ideas work. So I do see sometimes, unfortunately, some Stanford freshmen join us already knowing how to code and have implemented some learning algorithms, but some students that do not yet have much experience try to jump into research project right away. And that turns out not to be very productive for the student or for the research group because until you've taken the courses and mastered the basics, it's difficult to understand what's really going on in the advanced projects, right? So I would say this is actually worse than that, right? This is actually okay. This is actually pretty bad. I would not do this for your career, right? Probably not, yeah. And then the other not so great mode that you see some Stanfordians do is get a lot of breadth and then do a tiny project here, do a tiny project there, do a tiny project there, do a tiny project there, and you end up with 10 tiny projects but no 1 or 2 really significant projects. And again, this is not terrible, but beyond a certain point, by the way, recruiters are not impressed by volume, right? So having done 10 lame projects is actually not impressive, not nearly as impressive as doing 1 great project or 2 great projects. And again, there's more to life than impressing recruiters, but recruiters are very rational. And the reason recruiters are less impressed by someone whose profile looks like this is because they're actually probably factually less skilled and less able at doing good work in machine learning compared to someone that has done a substantive project and knows what it takes to see the whole thing through. Does that make sense? So when I say, recruiters are more or less impressed, it's because they're actually quite rational in terms of trying to understand how good you are at doing important work, at building meaningful AI systems. Make sense? And so in terms of building up both the horizontal piece and the vertical piece, this is what I recommend. To build the horizontal piece, a lot of this is about building foundational skills. And it turns out coursework is a very efficient way to do this. In these courses, right, various instructors like us, but many other Stanford professors, put a lot of work into organizing the content to make it efficient for you to learn this material. And then also reading research papers, which we just talked about. Having a community will help you. And then that is often building a more deep and relevant project, right? And the projects have to be relevant. So, if you want to build a career in machine learning, build a career in AI, hopefully the project is something that's relevant to CS or machine learning or AI or deep learning. I do see, I don't know, for some reason, I feel like a surprisingly large number of Stanfordians I know are in the Stanford Dance Crew, and they spend a lot of time on that, which is fine. If you enjoy dancing, go have fun, right? You don't need to work all the time. So go join the dance crew or go on the overseas exchange program and go hang out in London and have fun. But those things do not as directly contribute to this, right? Yeah, I know. I think in an earlier version of this presentation, students walked away saying, Andrew says we should not have fun and should work all the time. That's not the goal. All right. There is one all right. There is the Saturday morning problem, which all of you will face, right? Which is every week, including this week, on Saturday morning, you have a choice. You can read a paper, or work on research, or work on open source, or I don't know what people do, or you can watch TV or something, right? And you will face this choice like maybe every Saturday, for the rest of your life, or for a lot of Saturdays for the rest of your life. And you can build out that foundational skills, go deep, or go have fun. And you should have fun, all right? Just for the record. But one of the problems that a lot of people face is that even if you spend all Saturday and all Sunday reading a research paper, the following Monday, or maybe spend all Saturday and Sunday working hard, it turns out that the following Monday, you're not that much better at deep learning. It's like, yeah, you work really hard, so you read 5 papers, great. But if you work with a research group, the professor or your or your manager if you're in a company, they have no idea how hard you work. So there's no one to come by and say, "Oh, good job working so hard all weekend." So no one knows these sacrifices you made all weekend to study or code open source and post. There's just no one knows. So there's almost no short-term reward to doing these things. But whereas there might be short-term rewards to doing other things, right? But the secret to this is that it's not about reading papers really, really hard for one Saturday morning or for all Saturday once and then being done. The secret to this is to do this consistently, for years, or at least for months. And it turns out that if you read 2 papers a week and you do that for a year, then you have read 50 papers after a year, and you will be much better at deep learning after that. Right? I mean, when you read, you have read 100 papers in a year if you read 2 papers a week, and so for you to be successful, it's much less about the intense spurts of effort you put in over one weekend. It's much more about whether you can find a little bit of time every week to read a few papers or contribute a bit to open source or take some online courses. And if you do that, every week for 6 months or do that every week for a year, you will actually learn a lot about these fields and be much better off and be much more capable at deep learning or machine learning or whatever, right? Yeah. So, yeah, actually, essentially, my wife and I actually do not own a TV, right, for what it's worth. But again, if you own one, go ahead, it's fine. Make sure don't drive yourself crazy and have a healthy work-life integration as well. Right. All right. So, so I hope that doing these things it's not about finding a job. It's about doing these things to make you more capable as a machine learning person so that you have the power to go out and implement stuff that matters, right? To do stuff that actually do work that matters. The second thing I want to chat about is selecting a job, right? And it's actually really interesting. I gave this part of the presentation last year, earlier this year, and shortly after that presentation, there was a student in the class that was already in a company who emailed me saying, "Boy, Andrew, I wish you had told me this before I accepted my current job." So let's see. Hopefully this will be useful to you. So it turns out that so when you at some point you're deciding, what PhD program do you want to apply for, what companies do you want to apply for a job at, and I can tell you what. So if you want to keep learning new things, I think one of the biggest predictors of your success will be whether or not you're working with great people and projects. Right? And in particular, there are these fascinating results from, what is it? I want to say from the social sciences, showing that if your closest friends, if your 5 closest friends, your 10 closest friends are all smokers, there's a much higher chance you become a smoker as well, right? And if your 5 or 10 close friends are overweight, there's a much higher chance you do the same. And conversely, if there's a so I think that if your 5 closest friends work really hard, read a lot of research papers, care about their work, right, learning and making themselves better, then there's actually a very good chance that that they'll influence you that way as well. So we're all human. We're all influenced by the people around us, right? And so I think that, and I've been fortunate, I've taught at Stanford for a long time now, so I've been fortunate to have seen a lot of students go from Stanford to various careers, and because I've seen how many hundreds or maybe low thousands of Stanford students that I knew, right, when they were still Stanford students, go on to a separate job. I saw many of them have amazing careers. I saw, a few have like okay careers, but I think over time I've learned to pattern match what is predictive of your future success after you leave Stanford. And I will share with you some of those patterns as you navigate your career. And it's just, there's so many opportunities in machine learning today. It's kind of tragic if you don't, navigate to hopefully maximize your chance of being one of the people that gets to do fun and important work that helps others. So when selecting a position, I would advise you to focus on the team you interact with. And by team, I mean, somewhere between 10 to 30 persons, right? Maybe up to 50, right? Because it turns out that if you there will be some group of people, maybe 10 to 30 people, maybe 50 people that you interact with quite closely, and these will be your peers and the people that will influence you the most, right? Because if you join a company with 10,000 people, you will not interact with all 10,000 people. There will be a core of 10 or 30 or 50 people that you interact with the most. And it's those people, how much they know, how much they can teach you, how hardworking they are, whether they're learning themselves, that will influence you the most, rather than all these other hypothetical 10,000 people in a giant company. And of these people, one of the ones that will influence you the most is your manager. Right? So make sure you meet your manager and get to know them and make sure there's someone you want to work with. And in particular, I would recommend focusing on these things and not on the brand of the company. Because it turns out that the brand of the company you work with is actually not that correlated. Maybe there's a very weak correlation, but it's actually not that correlated with what your personal experience will be like. That makes sense, right? And so, yeah. And by the way, and again, just full disclosure, I have a research group here at Stanford, right? My research group at Stanford is one of the better known research groups in the world, but just don't join us because you think we're well known, right? It's just not a good reason to join us for the brand. Instead, if you want to work with someone, meet the people and evaluate the individuals, or look at the people and see if you think these are people you can learn from and work with and are good people. That make sense? So, So in today's world, there are a lot of companies recruiting Stanford students. So let me give you some advice. And this piece of advice will good because I'll just give you the advice. So sometimes there are giant companies with, let's say, 50,000 people, right? And I'm not thinking of any one specific company. If you're trying to guess what company I'm thinking of, there's no one specific company I'm thinking of, but this pattern matches to many large companies. But maybe there's a giant company with 50,000 people, right? And let's say that they have a 300-person, right, AI team. It turns out that if you look at the work of the 300-person AI team, and if they send you a job offer to join the 300-person AI team, that might be pretty good, right? This may be the group, whose work you hear about, that publishes papers, you read on the news. And so if you get a job offer to work with this group, that might be pretty good. Or even better would be, sometimes even within the 30-person AI team, it's actually difficult to tell what's good and what's not. There's often a lot of variance even with this. What's even better would be if you get a job offer to join the 30-person team. So you actually know who's your manager, who your peers, who you're working with. And if you think these are 30 great people you can learn from, that could be a great job offer. The failure mode that unfortunately I've seen several Stanford students go down. All right, so actually, this is a true story. There was once, several years ago, a Stanford student I knew that I thought was a great guy, right? I knew his work. He was coding machine learning algorithms. I thought he was very sharp and did very good work working with some of my PhD students. He got a job offer from one of these giant companies that has a great AI group. And his offer wasn't to go to the AI group. His offer was to join us, and then we'll assign you to a team. So this particular student that was a Stanford student that I know about and I kind of care about, he wound up being assigned to a really boring Java backend payments team. And so after he accepted the job offer, he wound up being assigned to a backend. And I apologize, if any of you work on Java backend payment processing systems, I think they're great. But the student was assigned to that team, and he was really bored. And so I think that this was a student whose career, I personally saw his career rising while he was at Stanford. And after he went to this, frankly, not very interesting team, I saw his career plateau. And after about a year and a half, he resigned from this company after wasting a year and a half of his life and missing out really on a year and a half of this very exciting growth of AI and machine learning, right? So this is very unfortunate. And it was actually after I told this story, last time I taught this class earlier this year, that actually someone from, actually it was actually from the same big company, emailed me and said, boy, Andrew, I wish you told me the story earlier because this is exactly what happened to me at the same big company. Now, I want to share with you a different, so I would just be careful about rotation programs as well. When the company is trying to recruit you, if a company refuses to tell you what project you work on, who's your manager, exactly what team you're joining, I personally do not find those job offers that attractive because if they can't, if they refuse to tell you what team you're going to work with, well, chances are, right, telling you the answer will not make the job attractive to you. That's why they're not telling you. So I'd just be very careful. And sometimes rotation programs sound good on paper, but it's really, well, we'll figure out where to send you later. So I feel like I've seen some students go into rotation programs that sound good on paper, that sound like a good idea, but just as you wouldn't, after you graduate from Stanford, would you want to do 4 internships and then apply for a job? That would be a weird thing to do. So sometimes rotation programs are, yeah, come and do 4 internships and then we'll let you apply for a job and see where we want to send you. And it could be a Java backend payment processing system, right? So, so just be cautious about the marketing of rotation programs. And again, if you do, what they say is do a rotation and then you join this team, then you can look at this team and say, yep, that's a great team. I want to do a rotation, but then I will go and work with this team. And these are the 30 people I work with. So that could be great. But do a rotation and it could send you anywhere in this giant company. That I would just be very careful about. Right? Now, on the flip side, there are some companies, I'm not going to mention any companies, but there are some companies with, not as glamorous, not as right, cool brands. And maybe this is a, I don't know, 10,000 person company, 1,000 or a 50,000 person company, whatever. Let's say 10,000 person company. I have seen many companies that are not super well known in the AI world, they're not in the news all the time, but they may have a very elite team of 100 people doing great work in machine learning, right? And there are definitely companies whose brands are not, the first companies you think of when you think of great AI companies, that sometimes have a really, really great 10-person or 50-person or 100-person team that works on learning algorithms. And even if the overall brand of the overall company, isn't as, is a little bit sucky, if you manage to track down this team and if you have a job offer to join this elite team in a much bigger company, you could actually learn a lot from these people and do important work. One of the things about Silicon Valley is that the brand on your resume matters less and less, right? Less than ever before. I mean, I guess, I think the exception of the Stanford brand, you totally want the Stanford brand on your resume. But with that exception, but really, Silicon Valley has become really good. Sorry, the world, right, has become really good at evaluating people for your genuine technical skills and your genuine capability, and less for your brand. And so I would recommend that instead of trying to get the best stamps of approval on your resume, to go and take the positions that let you have the best learning experiences and also allows you to do the most important work. And that is really shaped by the 30 or 50 people you work with and not by the overall brand of the company you work with, right? So the variance across, so there's a huge variance across teams within one company, and that variance is actually pretty bigger or might be bigger than the variance across different companies. Does that make sense? So I would, and if a company refuses to tell you what team you would join, I would seriously consider just doing something. Well, if you have a better option, I would do something else. And then finally, yeah, and so really, I guess I don't want to name these companies, but think of some of the large retailers or some of the large healthcare systems or a lot of companies that are not well known in the AI world, but that I've met their AI teams. And I think they're great. And so if you're able to find those jobs and meet their people, you can actually get very exciting jobs in there. Right? But of course, for the giant companies with elite AI teams, you can join that elite AI team. I mean, that's also great. Right? I'm a bit biased since I used to lead some of these elite AI teams. So I think those teams are great, but also some teams in yeah. All right. Lastly, just general advice. This is how I really live my life. I tend to choose the things to work on that allow you to learn the most and try to do important work. Right. So, especially if you're relatively early in your career, whatever you learn in your career will pay off for a long time. And so, joining the teams and working with a great set of 10 or 30 or 50 teammates will let you learn a lot. And then also, hopefully, and just don't join a cigarette company and hope, give more people cancer or stuff like that. It's just don't do this. Don't do stuff like that. But if you can do meaningful work that helps other people and do important work, and also learn a lot on the way, hopefully you can find positions like that. Right? That lets you set yourself up for long-term success, but also do work that you think matters and that helps other people. All right. Any questions before we wrap up? Yeah.
I have a question about important work. What are some topics would you think are would you regard as important? Because important can be different for.
What's important work? Right? Yeah, I don't know. I think one of the most meaningful things to do in life is to help other people, either advance the human condition or help other people. But the thing is, I'm nervous. I don't want to name one or two things because the world needs a lot of people who work on a lot of different things. So the world's not going to function if everyone works on computational biology. I think comp bio is great, but it's actually good that when people work on comp bio, my PhD students, mainly work on AI applied to healthcare. My team at Landing AI does a lot of work on AI applied to manufacturing, to agriculture, to some healthcare, and some other industries. I actually, especially the California fires burning, I actually think that there's important work to be done in AI and climate change. But I think that there's a lot of important work in a lot of industries, I think, right? So I actually think that, the next wave of AI, I should say machine learning, is we've already transformed a lot of the tech world, right? We've already helped a lot of the Silicon Valley tech world become good at AI. And that's great, right? Helped build a couple of the teams that wound up doing this, right? Google Brain helped Google become good at deep learning. The Baidu AI group helped Baidu become, good at one of the greatest AI companies in the world, certainly in China. And I'm very happy that between me and some of my friends in the industry, we've made a lot of good AI companies. I think part of the next phase for the evolution of machine learning is for it to go into not just the tech companies like the Google and Baidu, which I helped, as well as Facebook, Microsoft, which I had nothing to do with, as well as what else? Airbnb, Pinterest, Uber, right? All these are great companies. I hope they'll all embrace AI. But I think some of the most exciting work to be done still is also look outside the tech industry and to look at all the, sometimes we call them traditional industries that do not have shiny tech things, because I think the value creation there, as a surprise you could implement there, maybe even bigger than if you, actually, I'll mention one interesting thing. One thing I noticed is a lot of the large tech companies all work on the same problems, right? So everyone works on machine translation, everyone works on speech recognition, face detection, ad click-through rate. And part of me feels like this is great because it means there's a lot of progress in machine translation. And that's great. We do want progress in machine translation. But sometimes when you look at other industries, when I look at manufacturing or some of the medical devices things looking at, or sometimes on these farms, hanging out with farmers feel like in my own work or my team's work, sometimes we're stumbling across brand new research problems that the big tech companies do not see and have not yet learned to frame. So I find one of the most intellectually exciting challenges is actually to be constantly on the cutting edge, looking at these types of problems. There's a different cutting edge than the cutting edge of the big tech companies. So I think some of you will join the big tech companies, and that's great. We need more AI in the big companies, in the tech companies, but I think a lot of the exciting work to do in AI is also outside what we traditionally consider tech. All right, it's 12:50. So I hope this was helpful. And let's break for today. Oh, have a great Thanksgiving, everyone, and we'll see you in a couple of weeks.